नमस्कार दोस्तों, मैं हूं आपका होस्ट रोहित एंड वेलकम टू अवर यूट्यूब चैनल रोहित स्टॉक. In previous video, we have seen what are the qualitative properties which can affect the performance of calorimetry. What is mean by phi factor and how it affects the result of calorimetry. As well as we compare the different calorimetry on the basis of phi factor. In this video, we discuss about what are the properties and tests from which we assess the risk during the processing of powder or solid, and of course, limitation of these tests. For better understanding, we divide this topic into number of parts. We already discussed about importance of powder safety. If you have not gone through this video, I insist please go through it first for better understanding. Link of this video is shared in description box. So let's start our today's topic, powder safety part 1. So let's start our first test, DES test, for determination of explosive property of powder. DES test is conducted in order to determine if a powder is flammable or explosive when dispersed as a dust cloud. Every powder has a tendency to burn. However, the flammable nature of powder should be confirmed by conducting dust explosion screening test. Test procedure. The DES test is performed in modified Hartmann tube apparatus. The apparatus consists of dispersed base with compressed air provision having a 6 to 8 bar pressure. Arsenic vertical tube of approximately 1 liter volume. Constant arc transformer and brass electrode between which spark of the known energy are passed. The test procedure is to fix the arsenic tube to the dispersion base and fit it with electrode. This electrode are connected to a constant arc transformer. The transformer is used to create a high energy that is in the range of 4 to 10 joules between the electrodes. The electrical continuous arc discharge is applied between the electrode and simultaneously the powder is also dispersed into the arsenic tube by means of compressed air. This procedure is to be repeated for 3 times with a new sample every time. Dust explosion screening test is a qualitative test, hence energy evaluation or absorbed during the testing is not determined. Result and interpretation. The powder which comes under ST0H class showing no fire or explosion hazard. A powder which comes under ST1H class showing dust fire and mild explosion hazard. And a powder which comes under ST2H class showing explosion hazard. If the powder falls under STOH category, then quantification of minimum energy required to burn or explode the powder is not required. Hence, it is a go or no go test for minimum ignition energy and minimum ignition temperature test. But if the powder falls in either of ST1H or ST2H, then that powder should be tested for minimum ignition energy. Determination of ignition sensitivity of dust cloud. In order to determine how easily and with what quantum a dust cloud can be ignited, 2 tests are performed. They are minimum ignition energy, that is MI test, and minimum ignition temperature, that is MIT test for dust cloud. Minimum ignition energy test, that is MI test, is to determine the minimum energy required for ignition of dust cloud. Test procedure. MI is measured using equipment known as modified Hartmann tube apparatus. The apparatus consists of dispersion base with compressed air provision 6 to 8 bar, arsenic vertical tube of approximately 1 liter volume, brass electrode, capacitance bank for generation of spark, discharge of known energy between the brass electrodes. Initially, 500 millijoule energy is applied across the brass electrode and 0.5 gram of dust is dispersed through arsenic tube. If an ignition is observed, the energy is reduced further. The dust concentration are also varied along with spark energy until no further ignition occur. The minimum ignition energy MI is the lowest energy capable of igniting a dust cloud. The MI value can also be given as a range of value from the highest energy where there is no ignition to a lowest energy where an ignition was observed instead of fixed value. Example 5 to 10 millijoule. Result and interpretation. The powder having AMI value greater than 500 millijoule is less sensitive to ignition. A powder having AMI value 100 millijoule is moderately sensitive to ignition. A powder having AMI value 25 millijoule is sensitive to ignition, and a powder having AMI value is less than 10 millijoule is highly sensitive to ignition. Limitations of minimum ignition energy test. First, the test is for solid sample only and cannot be used for gases or liquids. Second, the AMI test is conducted at ambient temperature. However, AMI value are highly depend on many other factors like moisture content, particle size, presence of flammable vapor, etc. An increases in temperature reduces the AMI value. AMI value decreases with decreasing in particle size. Increases in moisture content increases the AMI value. Increases in solvent content decreases the AMI value. This is because the solvent have very low AMI value, usually less than 1 millijoule. This is the reason because of which solid containing volatile solvent may not give reliable result in this test. In this table, a general basis of safety against AMI value are considered. Avoidance of ignition source and flammable atmosphere are the two common points for all kind of AMI values. Note that this is very general basis of safety and actual basis of safety can be varied on case to case basis. तो आज की वीडियो में सिर्फ इतना ही. If you really find this video worthy for you, then please like and share this video. And don't forget to subscribe our channel, which really boost our morale to bring such quality content for you. तो मिलते हैं हमारे अगले वीडियो में पाउडर सेफ्टी पार्ट 2. तब तक के लिए मैं रोहित साइनिंग ऑफ. बाय बाय.